Hi everyone. Today we are going to see in water technology external treatment we are going to discuss. External treatment. External treatment. So first of all you must know what is definition for external treatment we will write. So what is the definition for external treatment? Removal of impurities or salts from boiler feed water before feeding into the boiler is called as external treatment. Have you all understand? That is what is meant by boiler feed water. Boiler feed water means boiler feed water. What's the meaning? Boiler feed water. Water fed into the boiler. That is, water which is taken in the boiler is called as boiler feed water. So, how this water has to be? This water must be free from hardness causing salts, oil and greases, and dissolved gases and dissolved salts. It should be free. Then that is, the water should be pure. Then only the lifetime of the boiler will be good and the steam production will be good. So if you are taking in industry, there are water is used in two ways. Mainly it is used. The first use is it is used as a coolant. The second use is water is used for steam production. Which apparatus is used to produce steam? Boiler is used to produce steam. Clear? So this boiler feed water means it should be free from hardness causing salts. It should be free from hardness causing salts and it should be free from dissolved gases and it should be free from dissolved salts and it should be free from oil and grease. Okay, so oil and grease. If it is present, what will happen? Boiler troubles will arise. Okay, scale and sludge, priming and foaming, boiler corrosion, castic embrittlement. These are all the boiler troubles will arise. So to avoid this, to avoid boiler trouble in boiler, what we have to do? We have to do external treatment. External treatment in the sense, water, we are removing the impurities from the water before feeding into the boiler. So then it is easy for us. If it is enter into the boiler, afterwards if we are removing the impurities, then that is difficult for us. We have to apply chemicals and all. Before feeding into the boiler, we are removing the impurities. That method is called as external treatment. Okay, so definition in short, if you are writing means, what you can write? Removal of impurities, removal of impurities from boiler feed water, before feeding into the boiler. Before feeding into the boiler. That is called as external treatment. This is the definition. This definition carries 2 marks. Suppose if the question is asked as a detailed answer, first of all you have to write the definition. Then the next, what you have to write? What are the method we are having? External treatment method. There are 2 methods we are having. First method is zeolite process. First method is zeolite process. And the second method is demineralization process or ion exchange method. Ion exchange method or demineralization method. Demineralization method. So Now we will discuss first in detail about zeolite process. Okay. So first, if the question is explain zeolite process, or sometimes they will ask another name for zeolite is permitude. Another name for zeolite is permitude process. Otherwise, we can call this as softening method. Okay. So, there are, if the question is asked as a zeolite process, then it is a direct question. You may study. Suppose if they are asking us permitude softening process, means also again the same external treatment only you have to write. Suppose if this is a question, zeolite process, how you have to represent. First, you have to write the definition for external treatment, and this is one of the type is zeolite process. Then, first of all, you have to write small introduction. Otherwise, what is zeolite? What is zeolite? Hydrated, this is very important, hydrated sodium aluminosilicate. This word you have to remember. Hydrated sodium aluminosilicate is called as zeolite. Is it clear? First word itself you have to write, means they will give 1 mark will be allotted for this. Hydrated sodium aluminosilicate is called as zeolite. Next side heading, what is the, first of all you can write this one as introduction or definition, anything you can write. Then next we are having the types. There are 2 types of zeolite. There are 2 types of zeolite. What are the 2 types? One is natural zeolite. Natural zeolite. Another one is synthetic zeolite. Natural zeolite. Another one is synthetic zeolite. Natural zeolite, under that you have to write 2 points. Synthetic zeolite, you write 2 points. So, where this natural zeolite is present? It is present in green sand. It is present in green sand. Okay. Whereas this is synthetic zeolite. This is only called as permitude. Synthetic zeolite only called as permitude. That is, we are preparing. Okay. Then the structure, if you are taking, this natural zeolite is non-porous in structure. Non-porous. Whereas a synthetic zeolite is porous. Non-porous, and this one is porous structure. Okay. Porous, moreover, this is gel-like structure. Gel-like structure it has. That is why we are using this. Okay. So, this is something about the types you can write. Natural zeolite, synthetic zeolite, and natural zeolite is present in green sand and it is non-porous in nature. Synthetic zeolite means it is called as permitude, and this is porous and gel-like structure. This is how you can write 2 points. Okay. Then afterwards, what you have to write is formula. Okay. Formula for zeolite. I will write this alone. Okay. Then next what you have to write is formula. What is the formula for zeolite? How it is represented? That is Na2O dot Al2O3 dot XSiO2 dot YH2O. See, hydrated sodium aluminosilicate, isn't it? So, Na2O dot Al2O3 dot XSiO2 dot YH2O. What is this X? X value is a small number. Okay. So, this X value may be vary from 2 to 10. What is the Y value? It vary from 2 to 6. That is, x may be 2 or 3 or 10 likewise. Y may be 2, 3, 4, 10, 6, up to 6 you can possible, it is that. So, this is the formula for zeolite. Okay. Then, there are two types of zeolite, types are there. One is gravity type, another one is pressure type. Okay. Zeolite types. Zeolite types. There are two type of softeners. Okay. Zeolite softener type. One is gravity type. Another one is pressure type. Gravity type means that is because of gravitational force, automatically the water, hot water will come down. Okay. Pressure type means we have to give pressure for it. Okay. So, this is the first introduction. Likewise, we have to write. Afterwards, you have to draw the diagram for it. Once again, I will repeat up to this. Zeolite process means, first of all, you have to write what is a zeolite, then types, then formula, and there are two types of zeolite softeners are present. That one you can write. Okay. Now, we will see the diagram for it. Zeolite diagram we will see. So, up to this time, I will conclude once again what we have written, that is what is external treatment. Definition we are writing, isn't it? External treatment definition we have discussed. Definition we have discussed. Then afterwards, what is zeolite? In the what is zeolite? In that what we are writing, first hydrated sodium aluminosilicate we have written. So, first definition, small introduction, definition, types, formula. Okay, these are the side heading we have completed. So, afterwards, what we are going to discuss? Diagram. Then afterwards, we will see the principle means you can understand easily. Okay, so these are the side headings we are completed now. We will see the diagram for this zeolite process. So, first of all, we are having the one cylinder like things, single cylinder, which is filled with the zeolite bed. Okay, so this is your outlet path, and middle we are having zeolite bed. This is gel like structure, pores are there. Okay, that is why automatically what we are passing the water, it will enter. Then at the top we are having one regenerative column. Okay. So, at the top also we are having, so this is your sodium chloride. Any diagram if you are drawing, you must mark the parts also, then it is easy for us. So, first of all what we have to take is here hard water I am taking here. So, hard water in the sense which contains hardness causing salts. Okay. So, this is your hard water. So, when the hard water enter into the zeolite bed, afterwards which water we are collecting, it is soft water. Okay. To show the difference, I will put a small dot. Then we can easily identify that. One is hard water, the outlet is soft water. Okay. Yes. So, we can mark the points for this. So, how I will enter here, one inlet I can put. So, what is this one? This is hard water. And what is this one? This is zeolite bed. So what is this? What we are collecting here is called as soft water. We can collect. If you open this knob, automatically we can collect. So that water is called as soft water. Clear? Hard water, zeolite bed, soft water. So what I am saying, hard water contains hardness causing salt. Hardness causing salt. Hardness causing salts means cations if you are taking. Which salt is hardness causing salts? Ca2 plus or Mg2 plus. These two are positively charged ions are called as cations. Okay, these two are actually hardness causing cations. Usually here in this method, in zeolite process, cations only removed. Okay, so we are passing hardness causing salt. Where this hardness causing salt is present? It is present in the hard water. Okay, so what we have to do means, what is the principle? This is the structure is over, diagram is over. Then the next what you have to see is principle. We have to discuss about the principle. What is the principle? Principle is nothing but very simple principle only we are having. That is, this is zeolite, how it is represented. In short, every time no need to write the full formula. In short, zeolite is represented as Na2Ze. Okay. Na2Ze. In short, we are representing as Na2Ze. Then this sodium zeolite contains sodium ions. Sodium, what is the valency? 1. Okay. So, this sodium ions, that is Na plus ions present in the zeolite are loosely held. Loosely held. So, what will happen? Automatically, when we pass hard water, okay, when we pass hard water, this Na plus ion replaces calcium, and magnesium ions. This is the principle takes place. This loosely held Na plus ions present in the sodium zeolite replaces Ca2 plus and Mg2 plus ions and forms calcium zeolite and magnesium zeolite. Okay, this is the principle. So, principle is a simple one, that is a loosely held sodium ions present in the sodium zeolite replaces a Ca2 plus ion and magnesium 2 plus ion. Where this Ca2 plus ion and Mg2 plus ions is present? It is present in the hard water. Remember, it is present in the hard water. In the diagram itself, if you mention this one, you can write easily. Okay. Then we will see how it works. That is the reactions we will see. Next side heading, reactions. What is the reaction takes place? Okay. So, what I am taking? Sodium zeolite I am taking. So, what are the salts? Hardness causing salts. There are some salts we can write, that is calcium sulfate. I will write first salt alone, okay, then it is easy to write the reaction. Calcium sulfate. The next salt, magnesium sulfate. Next salt, calcium chloride. Magnesium chloride. So, these are the hardness causing salt. Example I have written. Okay. Sulfates and chlorides of calcium and magnesium. Okay. Calcium sulfate, magnesium sulfate, calcium chloride, magnesium chloride. So, these hardness causing salt, where it is present? It is present in the hard water. Okay. So, what will happen? This calcium sulfate reacts with Na2Ze and it gives, what it gives? Calcium zeolite, CaZe plus remaining is Na2SO4. Okay. Next, magnesium zeolite, Na2Ze, and what it forms? It forms magnesium zeolite plus again sodium sulfate is formed. Next, calcium chloride if you are taking, what it happens? It reacts with Na2Ze and it forms calcium zeolite and NaCl. NaCl formula? NaCl. See, both are monovalent ions. We have to balance this equation. 2 Na, here 2 Cl, so you put 2 NaCl. Clear? Then the next one is Na2Ze and it gives magnesium zeolite plus 2 NaCl. Clear? So, this is the reaction takes place. So, this is reactions, these 4 reactions you have to write. First we are writing principles, now we have writing the reactions. Next side heading, reactions over. Next what we have to discuss? Working, how it works. That is the reactions only we are going to write in sentence. Okay. So, next side heading you can write it as working. How it works. What I am saying, when a hard water is fed into the cylinder, bed of zeolite bed. Okay, when the hard water is fed into the zeolite bed, then during that time Na plus ions are replaces or by the calcium or magnesium ions present in the hard water. This is called as this is your working. Okay, working is over. Then afterwards, now how our Na2Ze, this sodium zeolite is converted into calcium zeolite and magnesium zeolite. Okay. The next step is important step, that is called as regeneration. Okay. So, what is regeneration? That is when this regeneration will enter into the scenario. See, once this all the zeolite is exhausted, remember the word. We are so up to this principle is over, reaction is over, working is over, and then regeneration step when it comes, that is on prolonged use. On prolonged use. Prolonged use means if you use continuously or long period of time, if you are using, then during that time what will happen? Regeneration step we are going to discuss. Regeneration. Here the word, which word they will expect? That is exhausted. Exhausted means, what's the meaning? That is no Na plus ion is available for exchanging process. Okay, here actually Na plus ions are replaced by or exchanged by Ca2 plus and magnesium 2 plus ion. But here on prolonged use, which is exhausted, sodium zeolite is exhausted. Na2Ze, sodium zeolite is exhausted. There is no Na plus ions now to replace Ca2 plus and magnesium 2 plus. That is what will happen? This whole bed, now it is fully calcium zeolite. This whole bed may be now calcium zeolite or magnesium zeolite. There is no Na2Ze. So, what this is the time to regenerate the bed. During that time what we have to do? We have to close this knob and we have to close this also. Okay. Then what we have to do? We must pass. Which chemical is used to regenerate this one? NaCl. So, sodium chloride 10% solution. What's the meaning of 10% solution of sodium chloride? 10% solution of Sodium chloride is used to regenerate this zeolite process. That is 10% is sodium chloride, remaining 90% is only water. Okay. So, what is the regeneration reactions? What is the regeneration reactions? How you will write? See, very simple. If you write this one, the same thing only regeneration reaction also. So, now what's our product is there? Product is calcium zeolite regeneration reaction. You see, calcium zeolite and magnesium zeolite is present. So, along with this, what we are adding? NaCl we are adding. So, NaCl if we are add, what will happen? Again sodium zeolite is formed here. That is Na2Ze plus CaCl2. Similarly, if we add magnesium zeolite reacts with NaCl, so and it forms Na2Ze plus MgCl2. Magnesium chloride is formed. Once again, this sodium zeolite is regenerated from calcium and magnesium zeolite. Okay. So, this is the regeneration reactions. Okay. So, this regeneration steps, so many along with that we can do. First of all, we can washing and rinsing, then salting, everything we can do. Again, we can start the work, we can do it. But anyhow, according to your examination point of view, regeneration step means that is once on prolonged use, sodium zeolite is exhausted. There is no Na plus ions to replace calcium and Mg plus ion, Mg2 plus ions. That is why we are using, that is a zeolite bed is regenerated by 10% solution of NaCl. If not, at least you have to write the word sodium zeolite bed is how we can regenerate it, means it is regenerated by 10% solution of NaCl. The equation is must. Equation you have to write. Equations here we are having, calcium chloride and magnesium chloride we are having already. So, same left side become right side become left side. Okay. So, up to this regeneration is over. Okay. Then the next one what we are going to see is advantages of this method. There are 5 advantages you can write. Similarly, 5 disadvantages is also be there. First advantage we will discuss. So, next one is what we have to discuss is advantage. Next what we are going to discuss is disadvantage. Okay. First we will see advantage. Okay. The outcoming water, what is it called? Soft water. Okay. First one is soft water has the hardness value. How the value will be? The value is around 10 to 15 ppm. That is, it contains only less amount of hardness causing salts. Okay. Second point is this method is very cheap. Okay. Method is cheap. Then the next one is simple operational procedure. Otherwise, you can write simple operational procedure. Just we are passing the water, that's all. Automatically absorption process, everything will take place and it removes, it absorbs. Okay, loosely held ions replaces. And the next one, what we will take is, here there is no sludge formation. No sludge formation. What's the meaning of sludge? A small, soft, loose precipitate. Okay, non-adherent precipitate. It won't settle down. But here no such sludge formation takes place here. So, this method is good. Then the fifth one is requirement of the set, space requirement. It is minimum. Space requirement of the setup is minimum. Once again, these are the 5 points you can write. First one is the soft water or the outlet water has the hardness of low, that is it contains only 10 to 15 ppm, and this method is cheap. It has a simple operational procedure, no sludge formation takes place, and space requirement of this setup is minimum. Okay, so these are the 5 advantages we have to write. And the next one what we are going to discuss is disadvantages. Disadvantage. Here also we are having 5 points. First one, what is the disadvantage? First of all, turbid water cannot be treated. We cannot use the turbid water. Hard water we are taking, that hard water should not be turbid water. If you use turbid water, cannot be treated because it blocks. What will happen if you use? It blocks the bed, zeolite bed. It will blocks. Then the second one is acidic water. Acidic water cannot be treated. What will happen? It decomposes this structure of the zeolite. It decomposes the structure of the zeolite. So, acidic water also cannot be treated. And the third one is water containing iron and manganese. Water containing iron and manganese cannot be treated. We should not treat because regeneration will be difficult. If the water has contains iron and manganese means what will happen? It will react with the zeolite bed in a faster manner. So regeneration will be difficult. Okay. Then the next one is important one. Brackish water cannot be treated. Brackish water cannot be treated because brackish water itself contains sodium ions. So, there is no ions to replace it. So, it cannot work. So, brackish water we cannot take. And the last one is the soft water, that contains large amount of dissolved sodium salts. It contains dissolved sodium salts which cannot cause any hardness in water. Okay, it does not cause any hardness in water, but it cannot be used in boiler. Okay, we cannot. It contains large amount of sodium, dissolved sodium salts. So, what will happen? It cannot be used in boiler. Can't be used in boiler. So, where it is used as a coolant we can use. If you use in boiler, what will happen? What are the boiler trouble arises? Boiler corrosion may occur or caustic embrittlement may arises. These are the boiler troubles may arise because of this use of this one. Okay. So, once again I will repeat this disadvantages. Turbid water cannot be treated because it blocks the zeolite bed, and acidic water cannot be treated because it decomposes the structure of zeolite, and water containing iron and manganese cannot be treated because regeneration is difficult, and brackish water cannot be used here because brackish water already it has Na plus ions. So, there is no ions to replace, and the outcoming water from the zeolite bed contains large amount of sodium dissolved salts. So, which does not cause any hardness, but this water we cannot use it in the boiler. Suppose if you are using, it may cause boiler corrosion and or caustic embrittlement. Okay, so these are the 5 disadvantages are there by using this method. Okay, this is the zeolite process in detail we have discussed. In short, I will say what are the content. Once again I will repeat. Suppose if the question is asked, So in short, what you have to write if they ask zeolite process, another name for zeolite process is permutude process. Okay, first of all, you must write the definition for external treatment. In short, within 2 minutes, I will complete. So first of all, you have to write the definition, that is a removal of impurities from boiler feed water before feeding into the boiler is called as external treatment. Two types are there, two methods we are using. One is zeolite method, another one is ion exchange method. One method, zeolite method, we are going to discuss. Definition you write, that is hydrated aluminosilicate is called as zeolite. There are two types of zeolite. One is natural zeolite, another one is synthetic zeolite. Then the next you have to write the formula Na2O, Al2, O3, X, SiO2, Y, H2O, X varies from 2 to 10, Y varies from 2 to 6. Then you have to take down this diagram, hard water, zeolite bed and soft water. Then you have to write the principle, that is loosely held Na plus ion replaces Ca2 plus ion and Mg2 plus ions present in the hardness causing salt. Then you have to write the equations. Then you have to write the working, that is when hard water is fed into the bed of the zeolite bed, it replaces, it exchanges hardness causing ions, okay, and forms calcium zeolite and magnesium zeolite. There are two types of zeolite softeners we are having. One is pressure type and gravity type. And the next one is regeneration. On prolonged use, the zeolite bed is exhausted, so it has to be regenerated by using 10% solution of NaCl. For that, you have to write the equation. And the next one, 5 points of advantages and 5 points of disadvantages. Advantages in the sense, this method is cheap, simple operational procedure, hardness is having low hardness water is produced, and the space requirement of this setup is a minimum, no sludge formation. This is advantages. Disadvantages, turbid water cannot be treated because it blocks the bed, and acidic water cannot be treated because it decomposes the structure. Water containing iron and manganese cannot be treated because regeneration will be difficult. Brackish water cannot be treated because already it has Na plus ion, so no replacement takes place. And the outcoming water, soft water, contains dissolved sodium salts, so this water cannot be used in boiler. That's all about the zeolite process. Thank you very much.